In this video, we're going to explore an alternate way of doing the logic for our previous demo. So think of this as an extension to demo number 2. I'm going to reload the configuration from that demo, and I'm going to select the logic for signal number 1. And as you recall, it was fairly complex. What I'm going to show here is a way of really simplifying the logic based on the way that this process actually functions. If you'll recall, this was an approach signal, and it involved 2 turnouts that could be set opposing the direction of travel, and also 2 additional blocks that could be occupied that would affect the state of the signal as we approach it. The way we set this up originally, we had the default to be dark, as you can see from the first line here. Then we had 3 red indications that were based on the first block being occupied and either the turnout 1 being reversed, turnout 2 being reversed, or block 2 being occupied. We had a yellow condition, again, based on the first block being occupied, the turnouts both being normal, and block 3 being occupied, which was the second block down the line, which would result in a yellow signal. And to get a green signal, again, block 1 had to be occupied, and all the conditions had to be clear. So block 2 had to be vacant, block 3 had to be vacant, and both turnouts had to be normal. So I'm going to show a different alternative method of achieving the same result that will look a lot simpler when we're done. I'm going to erase all the logic here. The first thing I'm going to do is I'm going to change the default from dark to green. And right away, that will eliminate the term that we had down here for green, because now the default will be green and dark will be one of the conditions that we have to set. And we want the block to be dark whenever, or we want the signal to be dark, whenever input number 1, which is the number 1 block detector, is off. So if nothing is occupying that block, the signal will be dark. So we'll just add that logic line. That takes care of the approach signal part of the operation. Now that we've taken care of that, we can put in the other terms. So we can put in when turnout 1 is reversed, the signal will be red. When turnout 2 is reversed, the signal will also be red. And when block 2 is occupied, which recall we're using inputs for our block detectors in this demo, when block 2 is occupied, the signal will also be red. That leaves us one last thing, and that's the yellow condition on the signal. And basically all we have to put is when block 3 is occupied, the signal will be yellow. And that's the complete logic that we need, and it doesn't look much like what we had before, but here's the way this works. Starting with the first condition here, if block 1 is not occupied, then the signal goes to dark. And recall that these things are processed in sequence. So once that occurs, basically this is like an off-ramp. The logic goes no further and the signal will be dark because that item was encountered first in the logic. Following that, we have these individual conditions, each of which can set the signal red. And then finally, we have this yellow condition. Now, if you recall before, we had yellow as a combination of block 3 occupied, but also turnout 1 normal, turnout 2 normal, and block 2 vacant. The reason we don't need those terms here is because by virtue of the sequence in which these are processed, those possibilities have already been eliminated. by the time we get to this final line. So when we get here, we already know turnout 1, because it didn't set this red, turnout 1 must be in the normal position. Otherwise, we would have taken the off ramp right here, or here, or here, if any of these 3 conditions occurred. So the net result is we don't have to specify any of those conditions in the yellow state. And if none of this stuff is true, we go to the default condition, which is green. And that basically is the complete equivalent logic to what we had before. What we did before basically was detailed specification of the requirements for the logic. This allows you to really shortcut or do a kind of a shorthand version of that, and it works just as well.